The delta function is introduced by this kind of case, okay? Delta x. Okay? So this is x-axis and this is 0, okay? And we define the function wkx function, okay? This function defined by the height is 1 over, is half k. And this is 1 over k. It's 1 over k. So the width is k over 2 over k, right? And times it, so the area equal to 1. This is then, so wk, this function is defined as when the x value is between 1 over k is equal to k over 2, and x value larger than 1 over k is equal to 0. So this definition of wk is the figure like this. Okay? Yeah. So delta x is defined as limit k approximate to infinity and wkx. Okay? This definition of delta function of this. Okay? So as you can see, when the k getting bigger, it will like something higher, right? Smaller, it's like a very big. The area is equal to 1. Okay, no matter how big, the area is 1, right? Then okay, so actually the delta function actually the delta function has x on a function like this. So when you do the infinitive to infinitive delta x gx dx is like the limit k to infinitive minus infinity into infinitive wkx gx dx. So actually it's doing this, the limit of this wk. That's right. Just like a definition of this. Okay, so I replace the delta by this in here. All right? Yeah. So here we have a theory . A theory. What's that? If Wx is non-negative function, satisfy satisfying the integral of w x, the area is equal to 1. Okay? If a function is non-negative function and the area on it is equal to 1. Okay? Then k times w kx, okay, is defined as w kx. Okay. So for any function non-negative, I replace the x by kx and times kx. And t also has area equal to 1. Then from this, I define the new function wk. This is wk. Okay. Okay. Is a delta sequence. Okay. So for any k you choose and generate a function wk. If k getting bigger, so you vary the k value, so you will generate a different kind of w function, and you can see this is we call this w sequence, right? What's the meaning? Right. Yeah. Let's give you an example. Example given. If I have a wx is equal to 1 over pi 1 plus x squared, you can check. Yeah. Is non-negative. Non-negative, I mean positive, for all the x, for any given x, this is a positive value function, right? And also, integration minus to infinity wx dx equal to infinity 1 over pi 1 plus x squared dx, okay, is equal to 1 over pi arctangent x for infinity to infinity. So that will be 1 over pi. Arctangent is equal to half pi and infinity, right? So this half pi minus negative half pi, so it's plus half pi. So this is equal to 1. Right? Equal to 1. So check the theory. Equal to 1. Then, okay, then wkx is equal to wkx is equal to k w kx is equal to k times 1 over pi 1 plus kx squared. Okay, so it's equal to k over pi 1 plus k squared x squared. Okay, so if you plot this function, okay. Yeah. Okay. So this is 0. You can try for some value it will like this. This is called K1 value. If K2 getting bigger than K1, you will get a signal like this. Okay. If getting bigger, okay. So it's a K3. It's K2. Rather than K1. Rather than K2. Okay. So for bigger and bigger, you get a signal like this. So, something like this. Okay, sharper and sharper. But it will see there is a band. There's a band, narrow band of this function. Okay. Yeah. So this is a delta sequence. Okay. So this is what I want to show you. This is a band about x0. Right. Yeah. Then here, so delta function x minus a, we're like this is 0, this axis, and this is a. The delta function is 0 will something like this. You will have a peak at a narrow band. Okay, so this is defined as if I do the integration from minus infinity with the delta x minus a with a gx dx, then it will have g at a. G at a. Okay. So any function operates the delta of x minus a. You just put the a value at a. Okay. Because you can think this way. If this is a function of gx, right? All the gx at this here are 0. Only at a very narrow band is not 0. Okay? All others are 0. So that's why we pick up g value. So this is a typical definition of delta function. Okay? So, what's the meaning? The meaning of this delta function is this meaning. That is the action of delta x minus a on gx is to pick out its value at x equal to a. Okay, pick up the value of g function at x equal to a. So this is the meaning of a delta function. the action. So this action about this function, so the integration, scanning over. So like scanning the dx, then when x very close to 8, then I pick out the value at g. So this is a definition of, so I use a definition, okay? Right? Yeah.